Alright, so it's time to install some software onto our training board. Uh, with this board comes a USB cable. The one side plugs straight into your computer. The other side is a C-type connector, and that will just connect straight to your board. When you click it in, make sure it's properly connected, and we are ready to start playing with software uploads. All right, you'll see little lights coming on the board once you've plugged it in. And I'm going to go now to our Arduino IDE, and we're going to look at how to set up everything so that the microcontroller is seen by either Windows or Linux or what other operating system you use. So first off, we can go to Tools, Board, and then make sure that we have the right board selected. If you don't see this ESP folder, it will mean that you did not install the library yet. So if you go here to the left-hand side, you'll see that if you type in ESP32, there's two libraries available. If I say, if you type in, it is in the search bar here on top. The one is Arduino, the other one is Espressif. So we of course going to use the Espressif one because that's the one that's been developed by the manufacturers and developers of the ESP board, we're not choosing the Arduino one. I've installed mine already, so that's why it shows update. Yours then will show install if it's not installed yet. Hit install, it will take about 5 minutes to do. Once installed, if you then go back to tools, to boards, you'll see your ESP folder there, and if you hover over it, you'll see all the different ESP boards available. The one that we look for is the ESP32 S3 board. Make sure it is checked there. And then a last thing, very important thing, is again back to tools, port, and make sure that it's on the right port. So a port is really, these are the USB ports on your PC. You'll have 4, 5, 6 of them maybe, depending on how big your PC is. And make sure that you click on the one that do say ESP32 family device next to that port. Then you are ready to go. Something else, just a quick way of doing it, you can just make sure here that it's the right board and that the right COM port is selected straight from this drop down. Now what I do have here is the basics of sketches. This is the smallest sketch, in other words code. Arduino call it sketches. We'll continue calling it code because we're not really working with Arduinos. We're just using the Arduino IDE platform. So we will look at this later on, but I can just tell you this for now. In setup, in the curly brackets, everything you put in there will run once you power up or reboot your microcontroller, but it will run just once, and then after that it will go and start executing everything in this curly brackets for loop hundreds if not thousands of times per second. So this is where you'll write all your code. As I said previously, we will mostly use AI to do it, but it's good to understand, for instance, even if you're going to use AI to code, to be able to say, you know what, in setup, all pumps should start off as not powered on, right? Because if you have 5 big water pumps as an example, and you start all 5 of them up immediately, the power drain on those 5 pumps will be so huge that it will probably trip your main circuit breaker in your house or on your farm or in your company. So you want to start them all switched off, and then in the loop you'll start them up one by one. Even in setup, if that's the way you want to do it, to say, okay, all pumps should be off. Now start pump 1, wait 5 seconds, start pump 2. Now, because it's only happening once your microcontroller starts up, or when you reboot your microcontroller, it will only happen this once, and then from there on it will just loop through the rest of your code. So all your main code will be between these two brackets. So let's see, I'm using this. You can use anything else. For instance, I'll go to File. We can go to Examples. This is one of the ones we're going to use anyway. Let's do Basic, and we do a blink sketch. Blink is just a very small little program that's going to blink the onboard LED on your computer on and off. So that's the example code right here. You can see this is the code, is this little bit of code sitting here. The rest is comments. So once you see a / with a star, it means everything after that will be a comment until you get a /. So this is normally where you'll put something like what this program is about, maybe even what employer or what programmer wrote it for you, and so forth. Also on comments, you can have 2 slashes, meaning everything in that line from when the 2 slashes started is also seen as a comment. So you can see that all these example type of files are heavily commented because it's examples. You can learn from it in the sense that digital write and the comment will be turn the LED on, and there's another one that says wait for a second. So it explains the code for you as you read through it. So what we can do is just say upload, and let's see what's happening. Immediately the output screen opens up for you so you can see what happens. As soon as you see a lot of progress bars like this, it means that the program is getting uploaded. You can see it uploaded 10%, 20%, and it continued until it uploaded 100%, and everything is set up without any errors. If I chose the wrong port or the wrong board, you'll get errors. For instance, if I choose COM1 and I run the code again, it will compile the code. Remember compiling, taking human readable code and change it into computer readable code. And you can see how it tries to connect to COM1 here at the bottom, and it fails because there's no microcontroller on COM1. It is on COM3. Easy way to fix that is from here, just say COM3, and you're all set to go to now upload it again. By the way, on Verify, what Verify will do is it will just verify your code without uploading it. But on upload, it will also verify the code, and if verified, then only upload it. So I seldomly use Verify. I just uploaded it because it will verify it anyway and not, upload it to the microcontroller if it finds any errors. So that's it. In the next lesson, we will start looking at conventional coding, and we'll also get the LED to blink on your board, and we're going to look specifically at pinouts, which is extremely important. So pinouts will be next, and we start with conventional coding. I have about 4 videos on conventional coding. It's just the most important part, so you can help yourself when you're going to code with AI. But at the same time, you will learn how to read and start training yourself on understanding the code if you so desire. If you're a guy that likes to go under the hood, then you will probably like to learn more about the coding part. Not needed, but you know, I'm one of the guys that like going under the hood and see what happens. I like to learn as much as I can about things, but many people are on deadlines and they just need everything to happen via AI. That's also good. So I'll see you in the next lesson.